So my talk is looking at the effects of a dynamic landscape on producing a stable habitat, changes in geomorphology, and their effects on freshwater mollusk radiations. A long-standing ecological question is, why are certain faunas more diverse than others, or floras for that matter? For example, well known that the tropics have higher diversity than many other places. But why? There are multiple differences between the tropics and other parts of the world. And two major contenders have been the relatively warm conditions or the greater environmental stability over time. When we look at our freshwater taxa, some key areas for exceptional diversity are ancient lakes, which would tend to support the stability idea, especially given that a number of these are not in particularly warm areas. Baikal, Orid, that are definitely outside the tropics. Titicaca, well, it's near the equator, but it's way up in the Andes, definitely not too warm there. Another good example here from plants, the South African floristic province is temperate, but has extremely high diversity. And a recent analysis found that climate stability over geologic time was the best correlate with the amount of diversity. Well, for our mollusks, here in southeastern North America, we have quite high freshwater diversity. It's primarily in the big rivers. How might the big rivers be stable places? Rivers aren't known for stability. It's proverbially, since ancient Greece at least, that rivers are constantly changing. Over time, rivers will tend to erode down, and so we go from a steeper to a flatter gradient. Riffles, rapids get eliminated into a relatively flat meandering system. Another key aspect of our river pattern, the diversity here in southeastern US, a lot of that is from the implementae and their host attraction strategies, which generally involve getting the fish to see the bait to be fooled into taking the glochidia. So we need water clear enough for the fish to see. Okay, if we're going to have a large, fast-flowing river, and clear, lasting a long time, we need, well, water, and also a persisting elevation gradient. Water? Well, we do have a lot of that, as this picture from my campus in North Carolina illustrates. The southeastern corner of a northern hemisphere continent does tend to get plenty of rain. West sides of the ocean have warm currents moving water away from the equator, like the Gulf Stream. And so there's plenty of warm water evaporating not too far off the coast to provide a significant source of moisture. Wind directions can bring that over our area. And we do also have some mountains that will promote orographic rainfall. How about the elevation gradient? Yes, there are some mountains around our Appalachians Ozark Watchtower system. But why is there any gradient there? The last plate collisions involved there were over 250 million years ago. Should be pretty well eroded away, but it definitely is not flat currently. A little strange if it's just been sitting there eroding the whole time. But we do have certain clues that point to some much more recent activity. A little bit of the area near the Virginia-West Virginia line has volcanic and shallow intrusive rocks dating back only about 40 million years. much younger than any other trace of volcanism in the whole eastern U.S. What's going on there? There's no plate boundary nearby to produce that, anything of that sort. Also, the Appalachian region has some ongoing earthquake activity. East Tennessee is a recognized region for earthquake activity. Nothing too big is hit there in historic times, but we do have geologic evidence that not that far back in the past, there have been some pretty big ones. On into central Virginia. There's also more seismic activity, for example, on St. Lawrence Valley near the US-Canadian border. So it's not totally quiet here on the eastern front. Another peculiarity of our mountain patterns here is that the areas with the highest peaks in the southern Appalachians go across the major geologic provinces in terms of rock type. If this is just due to erosion and the more resistant stuff being left behind, then the mountain should match closely to the rock type. So that suggests that there's something not the surface rock that's our key player. And indeed, looking quite below the surface gives us a critical clue here. Careful analysis of earthquake waves traveling through the ground from distant large earthquakes gives a detailed picture of features down in the earth. And right under the southern Appalachians, we see this patch colored blue here of cooler rock down below the bottom of the plate. This figure, the details are from Hill et al. So this is indicating somewhat faster moving earthquake waves, and the main way to get earthquake waves traveling through something faster is have denser rock. In turn, denser rock is typically cooler rock. Why do we have this chunk of cool rock somewhat down underneath the plate? Well, it looks a lot like the bottom of the plate. So we seem to have had a chunk of rock break off at the bottom, perhaps someplace that was a little bit unstable, going all the way back to those collisions in the Paleozoic. And once that's detached from the plate above weighs a lot less, it's going to bob up, like taking weight out of a boat. A lot slower, but same basic principle. Similar events in the past could account for leading to the volcanism in the Eocene and various other features of the region. We may have had a series of these events through time. So our present-day Appalachian Ozark, these systems are not just the eroded remnants of mountains that were there when the dinosaurs first appeared. They have undergone much more recent adjustments and uplift. In turn, this changing geology has helped lead to more stable rivers. As the mountains have risen up, that's compensating for the rivers eroding down. And so we maintain a greater balance. Fast flow gives us coarser substrate, tends to give clearer water than if things were largely fine-grained, muddy conditions. The fact that our landscape has been changing over time may also help explain the patterns of endemism that we see, for example, along the Gulf Coast. A number of areas, we have relatively low divides between the rivers, not very high in the drainage, so high sea level would pretty much flood close to the entire basin, but we have species found there and nowhere else. But our landscape has had some significant changes. Perhaps in the past, these have been more isolated and larger to lead to getting unique species in the different regions. This is also providing some important cautions for molecular clock calculations. For one thing, in calibrating your molecular clock, one approach has been to look for some sort of paleogeographic event that would lead to separation of different populations. But do you have the right event? If you thought that two populations of snails have been separate since the Appalachians first formed, no, the separation is probably much more recent, only 100th of the age, perhaps. Also, once you have gotten a date, a popular thing to do is speculate on what different things going on at that time might have played a role in the divergence under consideration. But have you got up-to-date information on geologic understanding of what all was happening at that date? Our geologic understanding is being refined and improved. And also, there's a lot going on in the world at any one time. Identifying one single cause, probably not too confident there. What about other places? Well, we do see some similar patterns for Southeast Asia. Again, southeast part of the continent, we have plenty of rain there. Of course, Southeast Asia has development of a monsoonal system to give us lots of rain. We also there have a dynamic mountain system. In this case, India pushing into Asia is shoving up the Himalayas, been doing that for around 40 million years. And so as they're being eroded, they're also being pushed up and maintaining a balance that consistently gives us highland areas. And very high freshwater diversity across that region, as well as here in North America. Thank you. Are there any questions?